Welcome back to Between Two Vulns, where me and Dan do a group therapy session in front of the entire internet, and we occasionally talk about bug bounties. We have a doozy of report this month.
Yeah, I think we got 48 reports.
48 reports.
48. We've worked through a backlog, and some of these are a little bit older, but the amount of reports that are coming in has really never been higher.
Yes, which is great for you guys and awful for us.
Yeah, that's correct.
So let's get into the first one, shall we? I think this one is server-side template injection. Oh yes, I remember this. In the completions endpoint of BerriAI, I think that's how you pronounce it.
No, litellm.
Well, that's the, BerriAI, BerriAI, sorry, litellm. So this is interesting because, so the way this works, if I recall correctly, is that you have to basically trick somebody into using a malicious Hugging Face model with a JSON file in it that has an SSTI payload.
Right.
And
what is an SSTI? For those that don't know.
Yes. Please explain.
Oh, I was asking you.
Oh, well, I think it's server-side template injection.
That's correct.
But I've actually never exploited this myself.
Ah.
However, it seems like you can just use it to just run commands on the host if, I think, Jinja sandboxing.
Yeah, so like Jinja has this thing where you can wrap things in curly braces, and then it interprets that as part of the template. Sort of like a sub-HTML or something.
Yeah.
But yeah, you can end up getting command injection through that.
So actually, initially, so this is the thing with this, is that initially I thought you needed to trick somebody into using the malicious model. However, it's actually just like a server on your network that you configure to use that model. So technically, like, there really doesn't need user interaction required depending on the situation. So that's very interesting. And so huge shout out to MVLTT.
In my head, I always pronounce this as mutt. I know it's not right, but yeah, I don't know. It just kind of looks like mutt. But
oh, I guess
he's got some great reports.
Well, yeah, Molt, more like
Mavolt.
Mavolt.
Yep.
Maybe Mavolt. Yeah, shout out to him, and it's been fixed. So yeah, shout out to the litellm maintainer.
And with the money that you got from this bounty, please buy some vowels. That would be useful.
Yeah, that would be useful. Yes, correct, 100%. Okay, so the next one is NetAdder, right? Or NetAdder. I've always pronounced it NetAdder for some reason.
I feel like we could spend half this entire episode just how to pronounce people's names and how to pronounce projects.
Yes, exactly.
We're just going to say it however we feel like.
Yeah, so apologies, but not really apologies. So this is NetAdder, and I think this is, this is an IP address parsing library, which isn't in the default standard library. It's an optional, it's a third-party library. And this project had an issue with IPv4, IPv6 map addresses that aren't parsed correctly. There was like a whole Cloudflare thing that happened about this too, a while back, if I recall correctly. This, in our mind, is valid. The maintainer mentioned that this is more like a documentation update more than anything.
Right. So we can actually read the maintainer's response. They said, after thinking about the matter at hand some more and gathering more information, I don't consider the reported behavior to be a security issue per se. Can the API be misused? Yes. Does the API deliver what it promises in the documentation? Kind of. Is it reasonable for users to expect this API to not interpret IP version 4 mapped addresses in any special way? I'd say so. So I agree that this is a hard one to figure out if it's like a security risk or a QA bug. You know? And so we went with them. We agreed with the maintainer that we won't publish the CVE, but we'll publish the report because it's public no matter what, so it's irrelevant.
Exactly. We won't issue a CVE for this, but it definitely is something that everybody should know about. And I think was it actually fixed, or was it just, no, actually it was just a documentation update, so.
Right.
Okay,
so
fair enough.
It's one of those things where it's a local library, but it's commonly wrapped around, HTTP servers and stuff might take NetAdder and try and parse something. So I get it, but at the same time, that's also an architecture problem. If you wrap this in an API or an HTTP server.
Yeah, I could leave the CSRF.
Right.
Or SSR.
But then it becomes is this even a vulnerability in this library, or is that a vulnerability in your implementation of this library? Also,
I'm not exactly sure why you use NetAdder and not the default IP address module in Python these days. Like, NetAdder was sort of I think like it was there. It's been around for a while. I used it before Python had like a standard library, IP parsing library.
Right.
I'm not sure what, I actually don't know the difference, or why would you use this over the standard library one?
I don't know either, because I haven't used this for a long time.
Yeah, me either. I remember using it back in the day though, for sure. And then, there's the BentoML one, which was actually really good. So this is just a standard deserialization RCE. Well, I guess standard. I don't know if that's standard, but it's your run-of-the-mill deserialization.
Run-of-the-mill worst vulnerability
possible. Deserialization RCE in BentoML inference in the inference server, right? Yeah, in the BentoML inference server. So basically, you just randomly send a pickled object to the BentoML server, and it just runs whatever is pickled in the object. So
Right.
10 out of 10.
There's actually 2 of these vulnerabilities that I'll talk about after this.
Yeah.
We'll get through this one first. So big shout out to Pink Draconian. He's actually going to be here on several of these reports today. He's got really good reports. They're excellent to read if you want to see like good proof of concepts and stuff like that. But this is a great one because it's an HTTP server that takes pickle objects and deserializes them for remote code execution.
Yeah.
This is very different than a local library that loads pickle. Very, very different. That is local command injection, more or less. It's the
But
same
don't you
thing.
love local command injection?
I do not love local command injection. I don't think it's a very practical attack.
How many local command injections bugs have you
Several
triaged?
hundred.
Several hundred.
Yeah.
Okay, I mean, yeah. See, he has a tier for every
Yes.
local command
And
injection bug.
I'm going to get them tattooed.
Yes.
And so the thing is, we will give pickle deserialization reports a valid title on a CVE if they're remotely exploitable,
Yes.
exactly like this.
Yeah.
This is very good. I like this.
No, that is very good. It is great. Also, I forgot to shout out the person who found the NetAdder bug, by the way. But
yeah.
shout out to Amu, with a lot of O's. So shout out to him or her. And what else do we have? Oh, I think, yeah.
Oh, yeah.
What do
So
you
let me
got?
go
You got a
into
few.
the other ones that I like too.
Yeah.
There's 48 reports this month. Just insane.
Yeah.
Here's a few of the best ones. ReDOS and Fast API. ReDOS is not like something that we would usually shout out in these kind of discussions because it's a denial of service. It's not remote code execution. As a hacker, I can't get further into the network necessarily with this.
Yeah.
However, this is very interesting because it was actually found by none other than the famous, the handsome Marcello Salvati.
Okay, well.
If you notice here,
Hold on. Okay.
now let me read this. Hey, Tiangelo, my name is Marcello, and I work for the Protect AI / Hunter
listen,
Threat Research
it was
Team.
It was like my first week here, okay?
He's very happy to be here.
I was very, very professional back then.
Back then,
Yeah.
quick downhill
Quick
from there.
yeah.
But
As usual.
what's interesting about this is the fact that Fast API is like a fundamental library. It's incredibly popular for serving models, for doing all kinds of, like anytime you needed to stand up a server and make 2 servers communicate with each other with the code that you wrote, Fast API is a really good way of doing that.
Yeah.
But Marcello, even though he takes credit for this, actually did some more research on a different reporter's report.
No, this was originally found by some person called Nice Catch 2000. So shout out to Nice Catch 2000 for finding this. They submitted it to the WorkZug. I'm sorry for, I don't know how, I think it's German. I'm assuming it's German. Yeah, WorkZug, but I don't know how to, I should have probably read that up. But anyway, they submitted it to the WorkZug repository. They didn't consider it a vulnerability. And then I started playing around with it, and I found that Fast API was susceptible to it as well when it parses form data, not JSON though.
Yeah.
And then I submitted it to the Fast API repository. And shout out to Sebastian, right, for Ramirez for fixing this. And it was fixed a while ago at this point. I forgot when exactly, but.
So this is actually one of the fun parts of the job I think I've mentioned before is when someone submits a vulnerability and then we get to go do like extra research on top of that.
Yeah.
WorkZug is also like a phenomenally base level library used in
it's used in like Flask
and tons of architectures.
Yeah. And all the AWS GI implementations, I think. Yeah.
So this is actually a pretty interesting report, despite the fact I don't really want to give him credit here for it.
Yeah, exactly.
The other one is PyTorch RCE. Okay, PyTorch had an issue called ShellTorch a little while ago, which was really interesting, found by Oligo Security. It is where they had 3 interfaces up. They're running on port 8080, I think port 8000. I'm probably not right there.
8081.
Yeah, 8081, okay. And so one of those was the public interface. You're supposed to send API requests to that to get inference back from your PyTorch server. The other one was the management interface. And you could use a server-side request forgery on the public API on 80 or 80,000 or whatever it was, and send a request using server-side request forgery back to the management interface and then get command execution. And the problem was PyTorch was by default open to the entire network. It started on 0.0.0.0, not on localhost. So this made it quite impactful.
Yeah.
I mean, this PyTorch Serve is used on lots of cloud deployments. So somebody named Knight, thank you for the easy name.
Easy name.
Knight
Appreciate
found
that. You get extra reputational points if you have an easy name on huntr, by the way. The rest to pronounce.
Knight found that PyTorch Serve will actually also take .mar files, which is like a PyTorch model file, and you can upload that remotely, and then it has a deserialization bug that allows you to get remote code execution on PyTorch Serve.
Yes.
Now, we reported this to the AWS and Meta maintainers, and they said this is not a vulnerability, it's just a configuration issue. So they updated the security documentation to explain why. I'm not even sure what it was.
That they updated. Because there was something, I'm not even sure what they updated, because there was something there already that mentioned this. Like then they have like some command line flag that you can put in there in the serve the serve command line.
Right, so you can't
restrict
so you can't just upload random models to it.
Exactly, yeah.
But to fix to shell torch was for PyTorch to move to localhost alone and not on 0.0.0.0, which is exposed to the whole network. So they said this is a configuration issue because you're not supposed to expose PyTorch to the network, therefore RCEs aren't that big a deal. I think it's fairly reasonable that with as deployed as PyTorch Serve is, that people are gonna deploy it to the network. Because the whole point of it is to get inference out of a model.
Yeah, and you need to hit the inference, inference server to do anything. So
so you want to share it with one of your colleagues. Like, I'm pretty sure that there's going to be a significant amount of deployments that are deploying this out to the network.
Secure defaults. This all comes back to security.
So again, we just said, oh, that's fine. We won't issue a CVE, but we are going to validate the report and disperse the bounty.
Yeah, there you go.
So, because this is a great proof of concept too. If you want to go through, it's
it was a great report actually.
Yeah, I could just copy and.
You gotta love when you can literally just copy paste and everything works. Yep.
Yeah, so shout out to Knight for finding this one, and also shout out to the AWS and Meta devs. They got back to us very quickly.
Yeah, super quickly.
And they did their best to fix the issue. Yeah, those are the big ones I wanted to talk about.
RSA, we're gonna be there again next month. I forget the booth number, but please refer to the last episode for the exact booth number. And then what else? That's it.
I think that's about it. So we'll see you at RSA.
Yes.
And keep on submitting. Oh, like and subscribe.
Oh, yeah.
I am being reminded.
Smash that fucking
to say like and subscribe.
Yeah, just smash it.
Smash it.
Just destroy your monitor, really, with a hammer, preferably.
Ready to spotlight your skills? Join the hunt on huntr.com.